All right, lesson 10.5 is the probability of compound events. And remember in the last lesson we talked the difference between and or, and being when the probability or any event, as far as that goes, where both things have to be satisfied. Also, the word or, you only have to satisfy one of them. Okay, so in other words, like we wanted somebody that had blue eyes, and brown hair. So in other words, we've got to select a person that meets both criteria. They have blue eyes and they're going to have brown hair. If we use the word or, brown eyes or brown hair, then that actually satisfies several more people because they can have blue eyes and blonde hair. They could have brown hair and hazel eyes. They could have blue eyes and brown hair. So they could actually meet both criteria, but they only have to meet one when you see the word or. Okay? So before we start, let's start with a quick review. There are 3 marbles, 2 blue marbles, and 5 green marbles in a bag. So first of all, anytime we're finding probability, it's always helpful to go ahead and find out how many marbles we got. How many marbles do we have in the bag? And 3 plus 2 is 5. 5 more makes it 10. So we've got 10 total marbles in the bag. So in question number 1, the probability that we pick out a blue marble, well, we have 2 blue marbles out of our total of 10. Simplify it, and we have 1/5. Number 2, the probability that we have a red marble or a blue marble. So there's that word or again that we need to add. So our red marbles are 3. Our blue marbles are 2. So we add those up, we get 5 out of 10, which reduces to 1/2. Number 3, there's that word or again. So the probability of getting a blue marble is 2. Probability of getting a green marble is 5. Add them up, and we get 7/10. Number 4, probability of a red marble, a blue marble, or a green marble. So our red marbles are 3, blue marbles are 2, and the green marbles are 5. So we add them up, and we get 10 out of 10, which we have the probability of 1. So that kind of leads us into question number 5. What is the probability that an event will happen? And you find out that the probability of an event will happen is 1. So like in the number 4, that's all the marbles that are in the bag. Red ones, blue ones, and green ones. So if we want a red one, blue one, or a green one, we have a guaranteed chance that we're going to get a red, blue, or green one. Okay? All right. So when we're talking about compound events, basically a compound event is it's either the union or the intersection of 2 events. Okay, so in other words, yesterday we kind of talked about this a little bit, or in the last lesson. So when we do this, so first of all, the union is basically would include everything. So if I said, and this is where the or comes in. So if I wanted something that was in either A or B, then that would include where the star's at, because those items are in A. They're not in B, but they are in A. It would also include items where the square's at, because those items are in B, even though they're not included in A, because they have to satisfy both. It would also include the items like the heart right here that's in the center, because yeah, it's in A, but it also happens to be in B. So or is one of those. It just has to at least be in the 2 circles and be included in at least one of them. Maybe included in both, but it has to be included in at least one. The next one is the intersection, and the intersection is basically, it's going to have to be in both of them. So again, if we did the star is not included, and this is where our and comes into play. So if I wanted something that was in A and B, then the star wouldn't be included because it's only included in A. If I wanted B, well, in this case, the square is only in B. It's not in both of them. The heart is the only thing that actually satisfies that criteria. Okay? But basically, what we're going to be focusing with today is the union and that word or. And if you remember, this is in a biggie. Or means to add when you see that. Okay? So let's take a look. So if I want, let's look at the example before we look at the probability of A or B. This is the probability of compound events, compound 2 events happening. So in other words, I want to know the probability of getting an 8 or a diamond. Okay. So there's that word or again. Well, if I wanted an 8 or a diamond, here are all my diamonds. And if I count them, I find out I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 diamonds out of a total of 52 cards. Okay? Or means to add. And if I count the number of 8s, sorry I did that backwards, but if I count the number of 8s, my 8s are included right here. 1, 2, 3, and it actually includes the 4th one. But if you'll notice, when I'm counting these up, 13, 14, 15, 16. So the answer is actually 16 out of 52, which then can be reduced. But if you count up the number of, if we're doing this in an OR, count up the number of diamonds, I get 13. Count up the number of 8s, I get 4. One thing that you have to do is you have to take out that 1. So how many cards fit into both categories where they're an 8 and a diamond? Because we counted it in the 8s and we counted it in the diamonds, we have to take it out because we counted it twice. So we're just going to subtract that 1 out of 52, and that'll get us to our 16 out of 52, which reduces to 4/13 as our final answer. Okay, so basically our formula is, and this is what you need to make sure and have written down, that find the probability of the first event. So like we found the probability of the 8s, there were 4 of them. Then find the probability of the second event, and then you need to ask, is there any overlap where both events could happen at the same time? So in other words, I could get an 8 and a diamond. And in this case, there was one possibility that could happen. Okay. All right, so let's take a look at another example. Still dealing with cards. But I want to know, what is the probability of randomly selecting from a standard deck of 52 cards, what is the probability that we get an ace or we get a face card? Okay. So you count up the number of aces. 1, 2, 3, 4. So I have 4 out of 52. There's that word or, plus, and I have 12. Here's 3, 6, 7, 8, 9, 10, 11, 12. So I have 12 out of 52. Now these are actually called mutually exclusive because we don't have any cards that are going to be both an ace and a face card. So there's no and to actually subtract. So this one again is going to be 16 out of 52, which reduces to 4/13. Okay. All right, question number 2, or example number 2. A card is randomly selected from a standard deck of 52 cards. What is the probability that the card is a heart or a face card? So there's that thing again. So first of all, we need to find the probability that we have a heart. So we count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 out of a total of 52 cards. Or tells us we're going to add, and we count our face cards. 3, 6, 9, and we have 12 out of 52. But then again, you've always got to ask that question. Sometimes you'll have mutually exclusive events. Sometimes you will not have mutually exclusive events. And you always have to ask, how many of them are both heart and face cards? Well, those are these 3 cards right here. We have 3 of them that fit into both categories. And since we counted them twice, we have to make sure and take them out. So 13 plus 12 gives us 25. Subtract the 3, we get 22 out of 52, which reduces to 11 out of 26 as our final answer. Okay. All right, so this can actually be extended also into just about any other type of problem. So it says of 100 students, 34 are taking Algebra 2, 26 are taking Geometry, 10 are taking Algebra and Geometry. So what is the probability that we pick a student that is taking Geometry or, and there's that word or, Algebra 2? So we have to look, okay, how many students are taking Geometry? And we have 26 that are taking Geometry out of a total. Now this is like the one that we did in the last lesson where you're cut with your cousin's farm. You can't simply add up 34, 26, and 10. A lot of times they will give you the information, and in this case, we have a total of 100 students. Okay, that word or means we're going to add, and then we need to find out how many students we have that are taking Algebra 2. And we have 34 of them that are taking Algebra 2 out of 100. And then you still have to ask the same question, because could a student take both geometry and Algebra 2? And the answer is yes. And in this case, we have 10 of them. So we need to subtract off the 10, and we get 100. So 26 plus 34 gives us 60, minus the 10, and we end up with 50 out of 100, or 1/2. Okay, let me simplify those. Okay. All right, so example number 4. Let's go ahead and do this one as a U try. It's very similar to the last one. So if you want to go back and take a look at how we did this one prior to trying to solve this one, feel free. Leave it as an example. So I'll go ahead and pause for just a second and let you solve that. All right, so in the survey of 200 pet owners, 103 own dogs, 88 own cats, 52 owned both a dog and a cat. What's the probability that the respondent owned a cat? There's that word or again, a dog. So first of all, we determine that our total is 200. So we need to know how many owned cats. We find out that there are 88 that own cats out of our 200. Plus, then we need to ask how many owned a dog. And we have 103 that owned a dog out of 200. Minus how many of them owned both. And we find out that it is 52 out of 200. Equals, and we get 139 out of 200 is our probability. Okay. All right, so the next question that I have is kind of leads into the next topic that we're going to discuss. And that is, there are 8 balls in a bag numbered 1 through 8. What is the probability that a ball you draw out is not 6? So if we got 8 balls in a bag, they each are numbered 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So I want to know, what is the probability that I'm going to get something that's not in a 6? So 6 is the only one. So you have to basically remember the probability of just finding the events, the possible events over the total events. So we just count them up. Not a 6, 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 and not a 6. So we find out that we've got 7 balls in the bag that are not 6. Out of how many total balls? And there are 8. So the answer is 7/8. Another way to approach this is we can find out what is the probability of getting a 6. Sometimes that's a better approach. And you find out, well, I have a 1 out of 8 chance of getting a 6. So then if I remember, perfect probability was 1. Okay, and 1 can be written as a whole number. So I can write it as over a whole number. So 8 over 8 minus the 1/8 also would give me whatever's left over. Okay, this is called the complement of an event. And the way that you're going to see it written is you're going to see it with a little apostrophe. So the complement of an event has that little apostrophe. And basically, what the complement is, it basically includes all of the events that are not included in A. So in other words, in the last one when I said, what's the probability of not getting a 6? Well, that's what the complement would be. Okay, so the events that are not included in that. We're going to read it as A prime when you see it. And the way you find it is you simply take 1 minus whatever the probability of event A happening. Okay, so let's take a couple of looks at these on how we would actually solve this in a problem. So it says a 6-sided die is rolled. What is the probability of not getting a 3? Well, remember, when we have a 6-sided die, we can do numbers 1, 2, 3, 4, 5, or 6. So if I solve this, what's the probability of not rolling a 3? Well, let's find the probability of rolling a 3. And we find out that that is 1/6. And all I have to do when I'm finding the probability that not happening, for that event not happening, is I'm just going to take 1. In this case, I'm going to write it as 6 over 6 minus 1/6. So it gives me 5/6. Okay. So the last example, what is the probability of not rolling an even number? Well, let's count up the even numbers. What is the probability of getting an even number? Okay. So 1, 2, 3. So there were 3 out of 6 that were even. You can reduce it at that phase if you want to. So to find the event, the even prime basically, just take 2 over 2, which is still 1, minus the 1/2 gives me 1/2 as my answer. Okay. So just as a recap, remember when you're finding the probability of two things we talked about today, referring to that word or. And remember, or means to add. And you're going to take the probability of the first event plus the probability of the second event. And you're going to subtract off if we have a case where we could have the probability could fall into both criteria. And the last thing was finding the complement. And when you're finding the complement, so if I wanted to know A prime, then you're just simply going to take 1 minus the probability of that event happening. Okay? All right. And that concludes lesson 10.5. Good luck.